Today we have a presentation about BLE, an important tool for identifying and managing flood risk. Our presenters are Shannon Brewer and Joe Martinenza. Shannon has 23 years of experience in helping the state and local governments with water resources and floodplain management projects, primarily focused on FEMA NFIP state and regional flood study projects. She's an associate with vice president in Dewberry's Atlanta office and manages a team of GIS professionals producing mapping products and analytical services for a variety of flood study projects across the country. Most notably, Shannon has been providing technical and project management support to Georgia DNR's state flood map program for the past 14 years. National engineer with Georgia DNR. He's nearly 25 years of experience in floodplain hydrology and hydraulics, with 20 years working directly with the NFIP. He currently manages flood risk products for the Georgia Flood Map program. He assists communities in determining BFEs, NFIP regulations, and NFIP processes. And with that, I'll turn it over to Joe.
Thank you, Emily. Emily, give me a thumbs up if you can hear me, or somebody. Okay, good. So that's all working good. So we can go ahead and go on to the next slide there. I don't have control, so I think it's Shannon. Shannon, if you want to wave to everybody. That's Shannon. She'll be speaking to us in a bit. She'll be driving this presentation as we go. This is sort of a follow-up to the last Lunch and Learn we have. I recognize some of the people on the participant list. They were on the call that I did last time, and thanks everyone for joining. Seems like we got a good group of folks here. We want to really dive deeper into base level engineering. I kind of touched the subject, but let you know that we'd be doing something later on, and later on is here. I think you'll find this data set, so to speak, and the tools that we've created to be very useful. And we welcome your feedback on ways we can make improvements to this as we go. But before we really get into it, I think I want to spend a little time talking about what is base level engineering. It's a term you may not have heard before. It's relatively new in the FEMA NFIP scape. But what it really is, it's a large, broad scale engineering analysis that really is done very accurately. So in years past, you were able to either get in there and look at the engineering on a stream by stream level and do a really good job, or you're able to do a broad, wide scale, say on a watershed basis, and the results wouldn't be all that great. Well, now we can do both. We can produce really good data, and we can produce it at a very large scale, which in turn saves us a lot of money. There's all sorts of things, benefits of this. They can really help you when you're talking about planning. You know, how does our development plan look? It could also help you. It can help you and us assess the quality of the effective information. Right now, you probably have maps, and there's a lot of data on there, floodplain data. We create these models, and we're able to compare the two data sets to see where maybe these are really different. So we should scope a project here to update the DFIRM maps, and that will it's able to give us a really good cost on investment. And I have a bunch of geese flying over my house. So I'm gonna reach over and close my window as I'm talking. I apologize. But Shannon, you can go to the next slide. So really, when you're talking about base level engineering, you have FEMA's goals, and then you have the Georgia goals. Georgia goals builds on top of what FEMA's goals are. Obviously, FEMA's putting a lot of money and effort into developing the BLE data, and Georgia wants to at least meet those goals, but we have a few additional ones in our mind. So let's kind of look at those. Why BLE? Well, FEMA wants to update its digital inventory. So not just in Georgia, but across the country, there are a lot of approximate zone A areas. Some are based on models, some are based on very old models, some aren't based on models at all. FEMA wants to build that inventory. We want all floodplains to be based on digital models with the most recent data. And base flood BLE data is one way in which we are doing that. So not only are we producing more accurate information, we are also updating how current that information is. So even in Georgia here, you look in, say, South Georgia, there are a lot of floodplains that were developed in the some in the 70s, a lot in the 80s, some in the 90s. They're just really outdated. They haven't really kept up with development in some of these areas. And quite frankly, they were based on what was the best available at the data at the time, but that's very crude data, and we have much better data. Um, Also, FEMA wants to deliver this stuff quicker to communities. So anyone who's been through the process of us updating DFIRM maps knows that we start a project today, it'll be 5, 6, even maybe even 7 years before you get to see that data. Well, FEMA's like, well, we'll have this we'll have this BLE data, and we'll be able to produce it pretty quickly. We'll be able to get it out to folks really quickly to use as well, because we're updating Zone A areas. Georgia's goal, so we took those goals and we said, well, what do we want to do in Georgia? Well, the first thing is we have over 15,000 miles of floodplains in Georgia right now that were based on the old National Elevation Data Set topography data, which had basically an accuracy in the 20-foot contour range. You can kind of see the map panel there. You can see that floodplain looks, okay if you put it on top of the old quad maps, but the picture down below it shows what that new floodplain would look like based on the new LIDAR data that we've been collecting across the state. So Hayden Blaze, the state NFIP coordinator with the DNR, he's been working hard to put millions of dollars into LIDAR, which has been a goal of FEMA. Of course, they're providing us with that funding. If anyone's on from FEMA, thank you. But we have those 15,000 miles, and we really need to update them and update them for the sake of so people have an accurate assessment of their flooding risk. During this BLE process, another goal is it'll help us increase community engagement. We are, as you know, we might not be in a particular county. If we do a study today, you might not hear from us again for 10, 15 years. It just takes that long to cycle around the state. Well, because we're able to do this BLE data and do it quickly, and not only develop it quickly, but deploy it quickly, you'll hear from us more often, and you'll have much more accurate data in smaller cycles, so to speak. Also, Georgia wants to develop tools. So it's not enough for us to do the engineering, but we want to develop tools that communities are able to then use to, use in their planning purpose, use in their floodplain management purposes, use for outreach to their citizens, those sorts of things. Shannon, you can go to the next slide. So looking at what our plan is here, you can see that some watersheds are popping up. This is our 3-year plan, FY 19, 20, and 21. You can see all the watersheds that we're going to be doing base level engineering. So why did we pick these watersheds? Well, the first thing is everything north of there is really the Atlanta metro areas in there, and we've done new modeling in those areas in the past, say 5 to 10 years. We've updated the Etowah watershed, the Chattahoochee. We're doing the Upper Oconee now. So we're covering a vast majority of the population in the state by doing those areas. So we said, well, we'll move south of the fall line. And the fall line, for those of you who don't know, is the area in Georgia that really, north of the fall line, you have mountains, you have rolling hills. South of there, it starts to get into more of the coastal plain, really flat areas. If any of you on the phone are from the South Georgia, you know what I'm talking about. And also below the fall line, because it's outside of that Atlanta metro area, a lot of the modeling is old or non-existent for these approximate zones. You'll see here on this map that the coastline isn't in our BLE area, but that's because we've recently did analysis in the coastline. In fact, they've been going, they, say in the past 10 years, we've started them and completed them. So they have really good data. Also down there around Lowndes County, Cook, Tift County, and other counties, there's a watershed, the Withlacoochee watershed. We're currently mapping that as well. So really by the end of 21, we're going to have that entire area is going to be covered with really accurate and up-to-date modeling. Okay, Shannon. So how are we doing? So I want to get into not an extremely technical engineering talk, but I think it's important to understand what we're doing and how that impacts the water surface elevation. So we really have two methods of hydrology and hydraulics that we're employing. 2D modeling using the rain on grid method is really where a lot of South Georgia's falling into. And that's because there's not a lot of relief. It's flat. Water, it's hard to tell which way the water's going to flow. You may have a stream running through there, but in your higher frequencies, water leaves one stream, goes overland, and ends up in another stream. And those really can't be modeled accurately with 1D models. So we're doing a lot of 2D modeling. So how does that work? Well, first we start with LIDAR data, and that data is either quality level 1, most, or quality level 2, which may not mean anything to you, but just note that it is very high quality data. It allows us to get in and delineate those watersheds so we have a better idea where the water is actually flowing. If a raindrop hits here, we can tell which way it's going much more accurately. We also, when you're doing two-dimensional modeling, the big thing is to really calculate the rainfall losses. So you need to kind of do that up front before you can do the rest of the methodology. For the rainfall losses, we use either the curve number or the green amp loss method. Those are the two methods that seem to work best for our situation here in South Georgia. So that's what we're using. We also need inputs from the NRCS soil data, and we use the National Land Cover data set and the impervious data set kind of to figure out what those losses may be. Once we have the losses, we plop that into HECRAS, which now has 2D, well, it has had 2D capability for quite some time. We do a preliminary run. So we take a watershed or a large area, we do a preliminary run. And the thing about two-dimensional modeling is you use what's known as meshes. So if you see the picture over to the side there, you kind of, hopefully you can see the little rectangle, I guess they're squares, 250 foot by 250 foot squares. Those are known as cells. What HECRAS 2D is doing is it's computing inflows into the cell and outflow out of the cell. And what it does is it calculates everywhere there's a face, it does that calculation. So it can tell, is the water flowing north, south, east, west, or some sort of combination thereof. That would be fine. That would meet BLE requirements. You can run that kind of course. It's not coarse, so to speak, but it is, you can actually redefine those cells a lot better and make those smaller. The smaller you make the cells, the more accurate picture you get of where the flow of water is, where your flood risks are. Of course, the smaller the cells, the more calculations your computer has to do, and pretty soon you need a supercomputer to actually, do these things. So you got to find that trade-off. But there's some things that we can do, and I'll show you in a slide here in a second, some things we can do to hone in on those areas that might need a little extra bit of detail. Another thing that we do is we're doing the hydrologic and hydraulic modeling is we use the Manning's N raster, and we get that from the NLCD land use mapping. We add the channels manually. After we run these and after we better define the detailed areas, we go back and we calibrate the models. So you can run this 2D model and you can get an answer, but that answer may not be very good. So what we do is we go back to the regression equations, we go back to gauge data if it exists, and we make sure that our flows are falling in between the range of the expected range for the high and low values based on regression or modeling. Um, of course, at the end we'll have time for questions. So if you want me to get more specific on that, I certainly will. But that's it in a nutshell. And Shannon, if you can go to the next slide, we'll kind of look at how we add detail to this. So if you look at the raw mesh over there on the left-hand side, you'll see those 250 by 250 cells. And running through the middle of that cell is a road. Now, remember what I said, it computes inflow and outflow at each of those faces. And everything in the middle of that cell, it's not even looking at because it's not making computation there, which means it's not really, it's almost like the road doesn't exist there as far as the model's concerned. So it's not picking up the fact that the road is high. It's not picking up little low spots in the road. So it's, in essence, it's not accurately showing which way the water's flowing. So one of the things we can do is we can add a break line to the 2D mesh. What that break line does is several things. One, it'll start decreasing that cell size around the road. And you can't really tell there, but underneath that pink line across the road is actually a boundary for the cells. So it's actually at every along the road, it is calculating. It has a computational point there. It has a cell face there. So now it's picking up that road. It's picking up the high spots in the road. It's picking up dips in the road. The cell size is smaller, so we're getting a lot more computations. And now we're getting a really good idea of which way that water's flowing. In other words, the water's just not passing the flow through there as if there wasn't a road. And it makes for a much better model. Looking at that last one there, you can see that we have created a burn line. So what's that? That's a road, and there's actually a culvert there or a bridge there, and water is able to get through there. But if we don't break that, if we don't create that opening in the road, the model's not going to know there's an opening there, and it's going to give us, I don't want to say erroneous results, but it's going to give us some very conservative results, and the water may start piling up just upstream of there. So you can kind of look at the two pictures, and Shannon's highlighting. You can see that the flow has drastically changed once we've opened up the water and let it go through that opening, and that represents real life, the real world issues that are happening there. So we put in the break lines, we burn in the streamlines. It helps the model calculate the detail much better at those areas, and we put those in everywhere. Everywhere there's roads, we can put them in at lakes, we can put them in at dams. So we really spend some time making the model more accurate. Okay, Shannon. So looking at the 2D floodplain mapping, so now we have our model, it's been calibrated, it's got sufficient detail in the areas where it's needed. We have some mapping that goes along with this. So we map all the standard FEMA recurrence, all the recurrence intervals, sorry. But we also add the 1% minus and the 1% plus to this. Now, what is the minus and the plus? So those of you who are engineers or know a little bit about hydrology, you know that if you're using something like gauge analysis or the regression equations, there's actually an inherent amount of error that's built into that. So what we do is we take the highest predicted level and the lowest predicted level that we could get using either regression or gauge analysis, and we run those floods as well. So, you maybe go from somewhere to 100 and 200. We would use 150 because it's kind of in the middle there, but we also provide you with 100 and 200. So you can kind of get an idea of the range of values you can expect there. We also do the 1% future conditions, and then the BFE 1 foot, 2 foot, 3 foot. In other words, we're adding 1 foot to whatever BFE we get, 2 foot, 3 foot. So you can kind of see all those different mapping elements and how that may impact your development plans or current development. But not all floodplains are created equal. So if you look at this map down below, you'll see a purple and a blue and a pink and a green. At least that's how it looks on my screen. But there are really 4 different shades there. And what we've done is we want to classify this flooding based on two things, drainage area and depth, because those two things can really impact the severity of that flood. When you do a two-dimensional model, it's going to pick up a lot of little ponding areas over there by the cursor in Shannon. You can see those little ponding. Those are wet during the flood, but they may not have a lot of depth associated with them. And in fact, they may not have a lot of velocity associated with them. So the risk, the flood risk, the flood potential risk isn't as high for some of those areas as it is for the areas along the stream, which have higher depths, which have higher velocities, and all those things that go along with the destructive power of flooding. So we come up with four categories, and we show those to you. Those are all floodplain. Those are all can put areas at risk, but we want to show them differently. Now, if we get to the point where we're doing a flood risk project, what we can do is we'll work with the communities to kind of look at these shallow depth little ponding areas and decide, well, do we want to show those as A zone, or will we be better off showing them as something like X shaded, which doesn't carry that mandatory purchase requirement of flood insurance, but still shows the risk. So we'll work with the communities, we'll work with the FEMA regional office, and we'll come up with a plan that kind of makes sense so that people know that they're risk, but they're not necessarily we're not adding so much of. I mean, when you look at these maps later on, and Shannon's showing you some stuff, you'll see that a lot of South Georgia is going to be inundated because that's just the way that low-lying areas are. So we want to create this data set so that we can kind of take a look and start that conversation with community, start that conversation with FEMA, like how do we want to address this? Okay, Shannon, let's go to the one-dimensional slide. So there's two different types of modeling. 2D was one, it's most prevalent in the south part of the state. But we also have your traditional 1D modeling, which we do hydrology. That's based on the regression equations, unless there's gauge data available. And we will use that gauge data wherever it is available. You can kind of see that in the picture in the bottom right there. You'll see some gauges. You'll see some stream gauges, and you'll see the blue, which is basically where we use the regression equations. We calculate the flow for all streams that are a half a square mile, that have a drainage area of a half a square mile or greater. Sometimes we go above that if we need to capture a particular area, but for the most part, that'll cover about 99% of the area we need. Right now, we're using HEC-RAS 5.07. HEC-RAS has a beta version for HEC-RAS 6, which has some really cool stuff in it as far as two-dimensional modeling goes. So we can't wait for that to come out of beta and go into production so that we can start using that. But right now we're using HEC-RAS 5.07. The picture down here to the bottom right is how we deal with structures. Because these are approximate A zones, we don't go out and survey these structures. It would be too time intensive and too costly to do that for approximate areas. But we do include structures in a very similar way that I was talking about in that two-dimensional modeling. In essence, we open up that structure by looking at the aerial photographs, by looking at the LiDAR data, and we make sure that our cross section has that opening in there so water can get through. It's not ponding upstream of that structure and really producing erroneous, or I wouldn't say erroneous, but much too conservative floodplains upstream of that. Okay, Shannon, let's go to the next slide, actually. So applications of BLE. This is, like I said, we can produce this engineering data, and that's all well and good, but we need to make sure that it has applications beyond just what some engineer may want to look at it. We have four areas here that we've broken this into, really. So floodplain management, planning, risk communication, and emergency management. All these fields, all these areas of expertise in your community can use this BLE data. It can be used to, so just looking at a few of these, I'm not going to read them all, but floodplain management. BFE determinations is huge. I get 4 or 5 requests from communities every week. My colleagues get additional ones as well saying, I need help determining a BFE for this zone A area so I can figure out, how to permit this accurately. This BLE data can be used for that, and Shannon's going to run through that for you here in a little bit. Planning purposes, you can, as you're looking at planning in places where you might want to put a new park or things like that, having this more accurate data, having uh, let me take a step back and say, in South Georgia, there's a lot of floodplains, but a lot of the streams aren't even studied, so they don't even show up on the map. So you have no idea what the flood risks are. As a part of our program, we're studying all streams that have drainage areas greater than 1 square mile, which means in some counties, we are, doubling and tripling the amount of floodplains that they have access to. Now, that doesn't mean they're going to be on the DFIRM maps. Remember, again, we don't necessarily take BLE and create new DFIRM panels, but you will have access to that information that can be used for planning purposes. Risk communication, you have this information as a citizen says, I'd like to talk a little bit about floodplains. I don't understand why I'm in one or what that even means. This data set will certainly help with that as well. Shannon, if you go to the next slide here. So we have the engineering. So based on those things I said, we want to create some tools. So looking at a few of these tools, we're pulling together. The first one, I want to actually start a little out of order here, the Georgia BLE playbook. Now, this playbook is going to have in it, it's going to have a lot of the things that I talked about already, but it's also going to show you those 4 things from the previous slide. It's going to go in much more detail on how to use our data for those, how do I use this data? I'm an emergency management official. How should I use this data, or how can I use this data? Well, you can go to the playbook and that information will be in there. It will give you ideas on how to use that data. And of course, you'll come up with some of your own as we go. The Georgia BLE story map is a nice site that explains how to use the BLE data. It goes into some of the things with the playbook. It takes you to the BLE viewer. All this, there's a link there where you can go grab this stuff. But just know that the tools are underway. They're mostly developed. They're being refined right now. We are planning, as we create BLE data for various communities, we are going to be hosting some training on those. So we'll come in and give you a much more in-depth look of the data and how to access the data and a lot of the things that I talked about. So there will be some training where we go through the playbook and this Georgia BLE viewer. So I could ramble on for a while, but I think I'm going to stop here for a second. And before I turn it over to Shannon, do we have our first poll question here? Yeah, so let's do the poll question. Now, remember, as I think Emily said in the beginning, we need you to go in here and answer this poll question so that we can demonstrate that you were here. So Shannon, why don't you go ahead and open up that poll? So the first polling questions, open this up on your screen now. It says, which of the following are potential community applications of BLE? So we have 4 choices there. Select one or more of those that you think are potential applications for BLE. And we'll give it just a few seconds here. And Shannon, you just let me know when you want to close that. I'll take a sip of water. I want to make sure everybody has enough time to answer it. So you click on those. And
looks like we're still getting some answers coming in, so.
Okay. That's all right. I knew we might need a minute or two, so we had the time built in.
We've got about 20 folks that haven't responded yet.
All right. Well, we got about another minute built in here, so let's give it another 30 seconds or so, and then we'll close it down. What's going to, so I'll take you into what's going to happen. So I'm going to turn it over to Shannon here in a few seconds, and she's actually going to walk you through our BLE viewer. Now the viewer is just a web map. Well, it's not just a web map viewer. I'm pretty excited about it. It's a web map viewer with a bunch of things tied into it that I think is really going to help the communities with a lot of things, and that'll make more sense when Shannon gets there. Shannon, we're running down here, so actually we're going to close the poll in a few seconds.
Yep,
So
about
hopefully,
9 seconds, 8 seconds left, and we'll close it out.
okay.
We got
And then
most
after
people, it
that,
looks like.
okay, good. I'm glad. Poll has ended. There we go. So I think at this point, Shannon, I'm going to turn it over to you, and if you can take us through the BLE viewer, I think it'll really help people understand what we're doing a little better.
Okay, thanks. Hold on 1 second. I'll let this thing close up and save it.
Yeah. We got to make sure that we save this to our file so we have an accurate list. So let's make sure that happened before we move on. That is a good idea.
All right. Let's see. All right, so sorry, kind of poor timing, but my daughter's in the background trying to roller skate. So hopefully I'll not going to hear much of that starting in a second. So I took the lazy way out, and I'm going to do a demo, but it's actually a recording. So I'm going to pull that up, and fingers crossed that it all works smoothly. So 1 second, please. And Joe, if you could just give me a thumbs up if you hear it. Just access the BLE viewer. The 1% and 0.2% BLE floodplains are turned on. As I zoom in, you'll notice that building footprints start to appear. You'll also notice this gray masked area, which indicates that there is an effective detailed Zone AE study that should be used for regulatory purposes. Over here on the left, there's the legend that's also dynamic. There are other layers that we'll review in a few minutes that can be turned on and off, and as such, the legend will also change to reflect which layers are turned on and off. Over on the right-hand side, we have a few toggles, so we can change our base map up if we want. The viewer automatically defaults to topographic view. You're also able to search by an address. There's also an overview map, so you can see where you're at geospatially. Right now, we're near the border of Florida. And then again, this layer list, expansive layer list that we have here with a lot of different data sets. So the layers that are turned on are the ones with the eyes that are open. And then the ones that are turned off have the eyes marked out. So if I wanted to turn off the 1% and just look at the 0.2% floodplain, you'll notice that the legend changed to only show the 0.2%. If I wanted to look at the effective, I could turn that on, and as you can see, the legend changes. I can also turn on the 1% BLE and see how that compares to the effective flood hazard area. We also can turn off the 1% and the 0.2%. And now we have area changes from effective to BLE. So the red flood hazard area are the increases based off the BLE, and then the green are decreases, and gray is where you see no change. Georgia is producing BLE in 1D as well as 2D. So right now we're in a 2D area, and with the 2D, we're actually getting floodplains for areas with drainage areas less than 1 square mile. So there's a lot more floodplain being studied and added. With the 1D, we're making sure that there's studies up to the 1 square mile. So since we're adding so much floodplain with the 2D areas, we wanted to identify what areas are less than 1 square mile drainage area or have average depths less than 1 foot, or both, that meet both of those scenarios. And so this data set is shown as BLE 1% floodplain, potential moderate risk. So there is the flexibility or the option to show these areas as shaded zone X if this community was ever to advance to a risk map project. So let me turn off those layers, and then just real quickly, we have water surface elevations and depths for all the different frequencies that were studied. So there's a 1% water surface elevation and the 1% flood depth. There we go. We also have the probability of flooding over 30 years and the annual chance probability of flooding. Another neat data set that we have are the building footprints symbolized by map change. So the red would mean there's an increase in the floodplain based on the BLE, and green would indicate that there is a reduction in the floodplain and those are no longer in a high risk area. These would be good candidates for LOMAs going forward. So with that, I'm going to show you a couple of scenarios. So for this scenario, I want to show you what happens if you click on a building footprint within the 1% BLE floodplain. This window will appear and you have 2 map frames. Both of these are also dynamic. On the left-hand side, the BLE results are being shown, which is simply the 1% floodplain and the 0.2% floodplain. And then on the right, we have the changes between the BLE and the effective floodplains. Again, areas of increase are shown in red and areas of decrease are shown in green. Base map can be changed, as well as layers can be turned on and off in both of these maps. As I scroll down the page, there's a legend that shows all the different symbology for any of the layers that can be turned on and off in the 2 maps above. We're also able to provide the estimated BFE. So this is the base flood elevation coming from the BLE engineering. We also provide what the effective risk is for that location, which is currently low, and then the BLE risk, which is high or in the 1% annual chance floodplain. Also, where we have building footprints, we're able to calculate the lowest adjacent grade. If we don't have building footprints and you click anywhere outside or in the special flood hazard area, you'll simply get a ground elevation return and no value for lowest adjacent grade. Again, as I scroll down, more information appears. In this column, we have the flood depth based on the different storm frequencies, and then also the water surface elevations for each of those. And then at the very bottom, we provide the percentage of flooding in a year and also over 30 years. You'll also notice at the top, there's several tabs. The BLE summary is the window or the view that we're on right now. There's also a LOMA view, which we'll go into more detail in a second. Then there's the effective risk one, which basically takes you to the flood risk snapshot for that location. And also the flood model, which takes you again to georgiadfirm.com, where you can pull the model for this stream. One other functionality is printing reports. To print a report, you can do it in portrait or landscape. And here's an example of the report in portrait mode. So you have the map showing the BLE summary information. Again, the information provided in the pop-up window is shown here. And then the change map is available. And then change information. So the effective risk is low and the BLE risk is high. And then some general disclaimer and definition information for the report. The last scenario I want to show you is when a building footprint has been removed from the 1% effective floodplain and may be eligible for a LOMA. So when I click on this green building footprint, again, I get the same information that was shown earlier when a building footprint is in the BLE, special flood hazard area. You'll notice here that the estimated BFE for that location is 104.4, but the lowest adjacent grade is 106.4, which is why the building is now being shown out of the special flood hazard area. Now the other data is available for this location because that information is not calculated. There's no floodplain there. For properties that are potentially eligible for LOMAs, we have a LOMA view, which provides all the information you would need to support a LOMA based on LiDAR application. So we have the contour information for that location. We also have the LiDAR derived lag because FEMA requires a different calculation for lowest adjacent grade based off LiDAR to be a little more conservative. And then the estimated BFE. Still with the conservative calculation of lowest adjacent grade, is still higher than the estimated BFE. So that's good news for this location. We also provide the source of the LiDAR, when it was collected, and then the accuracy information and the reporting information associated with that LiDAR data set. And then also contact information is available here too. So you scroll down, there's a legend, and then we also provide instructions of how to submit a LOMA. In addition to that, you can also create a report here. So here's an example of the LOMA report. Again, you have the map view with the contours, and then all the supporting data information that's needed for a LOMA application based off LiDAR, and then the submittal instructions, as well as disclaimer and definition information. Here I want to show you is this extract data widget. So all the data that is published on the BLE viewer is available for download. You simply choose the method of identifying the area that you want to download. So I draw a circle here, and then I can choose the vector file type that I want, as well as the raster file type that I want. And then I pick the layers that I want. And then I click extract data, and the data will download. Okay, let's see. So I think that brings us to the second polling question, but before we move to that, I wanted to, can you hear me, Joe? Can you hear me? Okay.
Hear you just
All right.
fine.
Okay, I apologize, I don't have my video on, but I have a contractor in the house and I have a mask on, so I will save y'all from looking at me with a mask on. I wanted to make sure you could hear me okay through it. So we forgot to give you the answers from the first polling question. So the correct answers are permitting, mitigation, and risk communication. Hopefully you learned from the demo that you cannot replace effective zone AE studies where we have BLE, just because the level of accuracy for a BLE study does not meet the zone AE requirements. So we'll move on to poll question 2. Let me get that started and pulled up. Okay, one moment. All right, can you guys see it?
Yep, it's up.
Okay, so true or false, can BLE be used to support LOMA applications? We'll give you guys a couple of minutes to respond. Got about a minute left.
Bruce just posted up something in the chat. Please make sure you respond if you want the CECs for this. Even if you're not sure the correct answer, just make sure you respond so we know that you're here. Getting it correct or incorrect is not a criteria. Thanks, Bruce.
All right, about 10 more seconds. And we'll close it out. Okay, we're closing out now. The answer is true. It looks like most people got that right. True, it can be used to support LOMA applications. In the instances where the lag of the structure is higher than the effective BFE, then it can be used to support a LOMA application. Let me save that. All right. So that brings us to the end of the presentation. I'll turn it back over to Joe.
Okay, thanks, Shannon. So she's going to be pulling up a contact slide here in a
Joe,
moment.
we do have a real
Yes.
quick question. Can
Yep.
private residence owners use the BLE and submit for removal?
Absolutely. That was, if you think back to the viewer that Shannon was going through, there is that LOMA tab. That will provide you with all the information you need, including the instructions on how to submit a LOMA. It doesn't have to be a community; it could be a private citizen. Of course, the community can help them work through that if they need it, or us at the DNR. If a private citizen wants to call us up and get more questions, they can do that, or get answers to questions they may have. We can certainly help with that. But this information, and the reason you can use this information is because we're talking only about Zone A areas, approximate areas. since it's approximate, there are many ways in which you can come up with a BFE for that area. The state and FEMA, because we're going through this BLE exercise and creating all these wonderful models, that data is what's known as best available data. And it's best available data for anyone who wants to use it. Because of that, yes, a private citizen can go in and use that data and get the lag based on LiDAR, which is a little more conservative than you would if you hired a surveyor to come out and do that potentially. But all that information's there, and it's going. The BLE viewer is going to be housed on our website at georgiadfirm.com, and it's up on the screen there, or it was a second ago. Oh, it's right there, georgiadfirm.com /BLE, which means anyone will be able to get to it. Anyone will be able to use this data. This is public data. So as it's posted up there, they can use it. That's a very good question. So anyone can use the data.
Great. Thank you, Joe.
Mm-hmm.
We also just wanted to remind everybody the presentation will be emailed. We did have someone ask if the presentation can be downloaded, but it will be emailed out. We also had a follow-up question about the homeowners. Will this be available for Metro Atlanta area?
It is not available for the Metro. We're not currently doing BLE for the Metro Atlanta area. That's because we have the data already completed and it is up on our regular website. Shannon, I don't know if you're still driving. Can you pop up georgiadfirm.com and let's show them the snapshot real quick?
Sure, give me 1 second.
Yeah, sorry about that. But while she's pulling that up, BLE is for areas where we haven't done recent models. We've done recent models for the entire Atlanta metro area, and that data is already up there. And because it is effective data, it's up on our regular website. So you can just type in an address here on the home screen, and if you click on that address, it will take you to a flood risk snapshot. And that's click in the floodplain there somewhere. So if you were to click anywhere in the floodplain or on a house, you'd be able to, all that information over there to the right. So to give you the flood depths, it'll give you the lowest adjacent grade if it's available. It'll give you the water surface elevation if it's available. So all that data is put up there already. So that's a very good question. We're not going to be doing BLE in areas where we have more recent studies, but that data, because we already have model, everywhere we've done studies in the metro Atlanta area, we have model back zone A's. So that's a very good question.
Got another question. Will the shapefile / geodatabase files be available for county use? We use
Absolutely.
ArcGIS Pro.
Yep. Yep. You can. There'll be two ways. As we're doing the BLEs, we'll be giving the data to the community. So we'll be scheduling a meeting. We'll be doing some training. We will provide them with the geodatabase that has all the information in it. But also in that BLE viewer, at any time, there is that, towards the end of that presentation, there was that widget that you can go in and highlight specific areas and download either the shape files or the database, whatever you'd like to do there. So Shannon is pulling that up now. So you can do that for a smaller area, but we'll also be providing countywide information to the communities as we're finalizing the data. So when the data goes up on the website, we'll be scheduling a meeting with the communities and providing that information.
Okay. Another follow-up question about some of the areas where you've already done a lot of the studies. How about the zone A's that are in like the Upper Flint region?
The Upper Flint,
right,
if
like just below the Hartsfield Jackson.
Yes, if it, I'm trying to think if that falls into our BLE area or not. It probably does not. So if I showed that map early on of all the watersheds that we are doing, and Shannon's going to pull that back up. These watersheds here listed on the screen are the ones where we're currently doing BLE. And again, the areas around are just below the airport there. We have newer models that is up on our website. You can actually download the models. You can download the GIS data. You can do that little flood snapshot that Shannon showed us there. But this picture here shows you where we're currently doing BLEs. And really it's more than it's probably close to half the state that we're working on in a 3-year period, which is quite amazing really. But most of the stuff north of there and all the stuff around Atlanta have recent models. It's all Zone A, and it's all on georgiadfirm.com. And if anybody has any questions about how to get that data, feel free to contact me.
Great. Thank you so much, Joe and Shannon, for that very informative webinar. I hope you all now have a better understanding of BLE. We'll keep the chat open for a few more minutes so you can still submit questions, but please be sure to add your email address so that we can follow up with you. Again, we're offering 1 continuing education credit for today's session, available to the certified floodplain managers that completed both polling questions and right now put in your name and email address in the chat. We will be distributing this slide deck and a survey that we'll greatly appreciate you completing. Did we put the link up for the survey? No. Okay.
Yeah, Jim put it up.
Oh, okay. There's a link for the survey in the chat. If you can click on that because you've got a couple of minutes and go ahead and fill that out, we would appreciate it. If you're requesting continuing education credits, those certificates will be emailed separately. Finally, mark July 7th from 12 to 1 on your calendar for our next Lunch and Learn, and be sure to be on the lookout for the invitation to sign up and register for that wonderful next seminar that we're going to be having. Thank you again for attending today's event, and also thank you, Brian Shannon, for our opening questions and music as we were all logging in. For those who don't have any other questions, this is the end of our Lunch and Learn webinar. Have a great day, everyone.
Thanks, everyone.